So here are the solutions to worksheet 8.4. Question 1 was just going back over why we consider a proportion to be a binomial variable, essentially because we're just looking for two outcomes that we can consider a success or failure. In question 2, this is just from the notes, the assumptions that I have listed. Again, notice the similarity between the assumptions from sections 8.2 and 8.3 is that our sample must be a random sample. In the other sections, we were looking to see that our sample size was large enough as well as normally distributed for our variable. Here, the second assumption is that conditions for a binomial experiment must be met because of question 1. We consider it to be a binomial outcome or a binomial variable. And then C, again, sort of ties into our sample size. And if we took our sample size times our population proportion, or our sample size times the complement of that, it should be greater than or equal to 5. Question 3 is actually going back to previous chapters dealing with proportions. So these were just the two formulas there. If you weren't able to find them, please copy them down. All of our other problems were hypotheses tests. So for 4, I have everything written out here just to point out. Notice clearly in step 1, be very careful how you write this. Don't get in the habit of just saying H naught is equal to 0.686 because it's our proportion. In the other sections, we were looking at mu or population mean. Here it's our population proportion. So please make sure you're using P is equal to, and then the alternative here is that P is not, because our question is we're looking for a difference. So at the alpha equals a 1% level of significance, does that suggest a difference? So that makes our claim. Always make sure you identify the claim in step 1, that it's not equal to, P is not equal to 0.686. So to find our critical value, we're going to go into menu 553. This is a two-tailed test, so we're typing in half of alpha, so 0.005 for our area, and we get the critical value. Turns out to be plus or minus 2.58. For step 3, we want our test value, so p hat is going to equal 92 over 150, which is 0.613. Because it ended at the third decimal place, I'm not going to round it or change it. Q is equal to 1 minus 0.686, which is 0.314. So we're going to calculate this. Keep in mind that this denominator is the square root of everything here. So it's 0.686 times 0.314 divided by that 150. All of that is contained underneath the square root. So we get a negative 1.93. Making a sketch here, negative 1.93 falls between the two critical values. So in this case, we do not reject the null hypothesis, which a way to look at it means we have to keep it. So there's not enough evidence, and we want to use the word support. Remember, when our claim is the alternative hypothesis, we want to use support. So there is not enough evidence to support the claim that there is a difference from the national proportion. Now, again, in the homework, if you just stop it at there's not enough evidence to support the claim, that's fine. But remember, in your research report, you want to be very detailed. So when you mention step 5 and write that out, you want to go a little bit beyond and restate what your claim is again. All right, question 5 is a little different. I know I've been saying time and again that when we're the researchers, we pick our own alpha, but this was just a little exercise to help you find alpha in a different way, so to think a little more critically. So again, notice we're asked to find an alpha to be able to conclude that there is a significant difference, meaning our claim again is the alternative hypothesis. So here, null is that p is equal to 0.503, alternative is p is equal to 0.5, not equal to 0.503, and again, that's our claim. So we don't have alpha. We could guess and check, but this gets us to that step a little bit quicker. So I'm going to find the test value here and then kind of decide, well, if we definitely need to reject the null hypothesis to show that there's a significant difference, we could kind of locate where the critical values are going to be. So I'm choosing, or using the test value here. Notice I calculated p hat and q, and it turns out that the test value is 2.32. So I'm just treating this as both positive and negative so that we could kind of think of this as our critical values. But if I'm getting a positive 2.32, in order to reject, my critical value has to be what I have marked here in green. So I would need critical values that would be below the positive and above the negative, which will help. So what we're going to do is I'm going to use the negative 2.32. I'm going to go to menu 552 on the calculator, and I'm going to type in the negative 2.32 as the upper boundary. In a way, it's like calculating the p-value, but I'm going to use this as alpha. So the area that I get is really the alpha over 2, which is 0.1017. So alpha is going to be 2 times that, which is giving me a 0.02034. So really in this case, I could also look at this as the p-value. But I definitely know my p-value could be less than or equal to alpha. So I'm going to go a little bit larger. This will guarantee that my critical values are where I sort of located them on the sketch above. Or remember that p-value has to be less than or equal to this value. So I'm good at maybe saying just a little bit higher that alpha is equal to 0.025. I could set it equal to this, but I don't really want to go anything lower. And if you sort of tested this as well, maybe pick alpha to be that 0.025 and then go through and find the critical values and see that they would be located roughly where I have them sketched in. You can go a little bit lower, but even try going larger than that as well and see that the decision would still be to reject the null hypothesis. All right, looking at exercise 6, very similar. Our null and alternative hypotheses are stated here. The claim is the alternative. I find the critical value for 2. Again, this is a two-tailed test, so the question here is, does this differ from the national percentage at the 5% level of significance? So again, my claim is the alternative hypothesis. I'm going to type in a 0.025 as the area, getting plus or minus 1.96. The test value is calculated to be 2.51. So seeing this on the sketch, 2.51 is in the critical region, so I reject the null hypothesis. There is enough evidence to support the claim. So we're kind of kicking out the null hypothesis because we can reject it, and we go with the claim. There's enough evidence to support the claim. All right, number 7 ended up being a right tail test. So look at the null and alternative hypothesis. Again, the question here is we're looking for to see if there is sufficient evidence to conclude that the proportion of women's physicians exceeds 27.9%. So is greater than, that's going to be our claim. Since this is a right tail test, we're actually going to type in a 0.95 for our area. That's going to be to the left of our critical value here, and we get a critical value of 1.65. Calculating the test value, p hat and q I have calculated off to the right there, we get a 2.34. Since 2.34 is in the critical region, we're going to reject the null hypothesis and say that there's enough evidence to support the claim. And again, the claim is that we can conclude that the proportion of women physicians exceeds the 27.9%. All right, for question 8, we're back to a two-tailed test. Again, the question is there sufficient evidence to conclude that the proportion differs? So to show that it's not equal to means the alternative hypothesis is our claim, and we're given that p is equal to 0.856 or p is not equal to the 0.856 for our two hypotheses. Again, I calculated p hat and q off to the side. Two-tailed test, alpha being 0.05, we're going to type in 0.025. To find our critical values at plus or minus 1.96. Here in this case, our test value turns out to be a negative 1.02. Looking at the sketch here, it turns out to be in the non-critical region, so we do not reject the null hypothesis, which in a way means we go with it. So in this case, we would say there is not enough evidence to support our claim, again, because our claim is the alternative hypothesis. So now in the last 3 examples, we're using the p-value method. So we don't find critical values here. So number 9, there are 2 questions here. Just to read the whole problem again, it says a survey by Men's Health magazine stated that 14% of men said they used exercise to reduce stress. We're going to use that alpha is 10%. A random sample of 100 men was selected, and 10 said that they used exercise to relieve stress. Use the p-value method to test the claim. So the only claim we have is that this magazine stated that 14% of men said that they use exercise to reduce stress. So our claim in this case is the null hypothesis. And again, it's a two-tailed test because we're not showing any increase or decrease in that percentage or any other value here. So we're going with p is not equal to, so it's something other than the 0.14. So remember, step 2 now is to find z, which turns out to be negative 1.15. Now we go to menu 552 on our calculator. We're going to use that as the upper boundary. And the area that we're getting is 0.125, so we need to double that for our p-value at 0.25. So then we compare p-value to alpha, so our p-value is greater than, which means we do not reject the null hypothesis. We would say because our claim is a null hypothesis, we're going to use the word reject with this. So there is not enough evidence to reject the claim. And the second question here is, could the results be generalized to all American adults? And we can't say yes to that because only men were surveyed here. So just a follow-up question with our results. All right, looking at 10, again, we're using the p-value method. We want to test the claim that 18% of all high school students smoke at least one pack of cigarettes a day. So again, our claim is a null hypothesis. Writing this out, that our alternative hypothesis is that it's not going to equal 0.18. Again, step 2 is to find our test value. P hat is 0.167, Q is 0.82. Keep in mind this is a two-tailed test, so again we're going to use the negative 0.59, menu 552 on the calculator. Use negative 0.59 as the upper boundary, so the area we get is 0.278. P-value is double that. Compare our p-value to alpha. We're greater than it again, so we do not reject the null hypothesis. And again, there is not enough evidence to reject the claim that at least 18% of all high school students smoke at least one pack per day. All right, for 11, again, the p-value method. Here the claim happens to be the alternative hypothesis because that's the library director's claim. So again, just to go over the entire problem, for Americans using library services, the American Library Association claims that 67% borrow books. So that's their claim. A library director feels that this is not true. So the library director's claim is what we're looking at here, and that's the alternative. They think it's something other than the 67%. So for 2, we calculate the test value. Again, it's a two-tailed test. So in this case, because it came out to be a positive value, that is going to be our lower boundary. So we type in the 3.19 as our lower boundary, the infinity, or 9E999 for the upper boundary, and we get an area, because that's 3.19. That, again, is over 3 standard deviations away from the mean. That's at the very far right end. So we have a very small area, which makes sense by getting this 0.0007. Doubling that, we get a 0.014. Compare our p-value to alpha. It is less than alpha, so we reject the null hypothesis. Since our claim is the alternative, we say that there's enough evidence to support the director's claim. All right, so as always, guys, let me know if you have any questions over this or the chapter 3 and 4 review for the final exam. Let me know any questions.